That's just for the ones we know about. But what about the transition metals? So our transition metals have different charges. So how can we name them? We cannot determine the charge from the periodic table. And it gets worse. Most of them have various charges. So I like to think of it as they come in different flavors. For example, iron can be iron +2 or iron +3. Now, if an atom, it's a metal, has more than one charge, we have to tell our paper which one it is. And so we do that by using Roman numerals. So +2 just becomes Roman numeral 2. +3 just becomes Roman numeral 3. And we only have to use these charges, these Roman numerals, if the element we're talking about or the ion we're talking about has more than one charge. Like copper. Copper has +1, or copper can be +2. And if you have a +1, you do have to use this Roman numeral 1. But again, only if it has more than one possible charge. And we're going to talk about how do you know if it has more than one possible charge in just a minute. Okay, so, and again, a lot of these ones with pictures I don't have on the PowerPoint just because they're just examples. So how do you know if it has more than one charge? Well, group 1 is always and forever +1. So it never needs a Roman numeral. Group 2 is always and forever +2. So it doesn't need a Roman numeral. But others have multiple charges. So the ones we're talking about here are usually, remember that stairs I talk about? We're going to talk more about this. We're talking about these over here. Some of these change, and that's what we're talking about. So for example, lead. Lead can be +2, +3, or +4. And again, you're not going to need to memorize this. I'm going to show you how you can figure it out. But just remember, if it has a possibility of having more than one charge, you have to use these Roman numerals after the name. Now, some of them only come in one flavor. These 3 transition metals only have one charge. And because they only have one charge, we don't need to use Roman numerals. So how do you know which ones have one charge and those who don't? So here's just an example. Here's our ones that only have one charge. And all of these change. But again, you don't need to memorize those. I'm going to show you how to put this on your periodic table. Okay, so here's our stairs. And again, if you have a printed periodic table, you are welcome to write these on it. Just making our stairs. That's our stairs. We know that this is always +1. This is always +2, +3, -1, -2, -3. Now, if it's under the stairs, which I'm going to use a different color, let's use purple. If it's under the stairs, maybe purple wasn't the best choice. If it's under the stairs, it needs Roman numerals, except these. And I'm not going to use purple because you're not going to be able to see it. We'll use black. So there's the triangle that doesn't need Roman numerals. And what do I call the triangle? This is a +3. We already know this. This is a +3. This is a +3. This is a +2. This is a +2. This is a +1. Now, why do I call this our triangle? See how it's under the stairs, but it kind of forms like a little triangle? And there are 3 boxes. So there's 3 boxes, and these are all +3. 2 boxes, and these are both +2. 1 box, and this is a +1. Everyone else, except for that little triangle right there, needs Roman numerals. So on your periodic tables for your quizzes and your tests, you can put this little triangle here. You can kind of see behind me. I have that triangle on the periodic table back there. If we were in class, I took this from one of my classes, you would see this, that you can actually, the triangle, we have it on the periodic table often in lecture. Okay. So you can see, this is what you can have on your periodic table. So you can have numbers, and this is what I mean by when I say like on your quizzes and your exams, you can have a periodic table that you write on, but you can only have numbers on it, no letters. See, we have not put any letters on this periodic table. So when do you need to use Roman numerals? You need to use Roman numerals. Let me just erase this. If we are under the stairs, white is not good. We're just gonna have to go back to red. Any of these under the stairs except the triangle. So the triangle does not need Roman numerals. Okay, so again, probably put a star on this one. Remember where this is. This is what you can have written on your periodic table. Okay, so now let's practice this. How do you know the charges? It's like if you don't know the word in a sentence, you use the context of it. It's the same thing in chemistry. So we name the metal ion first, which is copper. But how do we know the charge of copper? Well, we do know the charge of bromine, right? Bromine is -1 because it's in group 7. And if we look at our algebra way, right, there are 2 bromines. This has to equal 0. So what must our charge of copper be? Yeah, copper has to be 2. It has to be a +2 because that's how we can get our math to work. Right? Because remember, the net charge of any ionic compound is always 0. So then we use, this is our +2, copper 2, and then it's just going to be bromide, copper 2 bromide. Now, you could also use the crisscross. Remember how we crisscross down? You could just crisscross right back up. So if you have Cu and you have Br, you can take this and crisscross this, and that would be a 1 right up. And so that's how you can know that this is a 2. But again, remember this crisscross method doesn't always work. Okay, so again, if we try a crisscross, let's just do this one here. If we crisscross this, if we put this up here, that makes this a +2, and bromine is a -1, so it'd be iron 2 chloride. Okay, what is copper's charge? I mean, yeah, what's copper's charge? Yeah, you can see it's a 1. And we have to put the 1 because copper is in the middle. Okay, so now tin. What is tin's charge? Sn. What is Sn's charge?
4.
Yeah, some people are getting this one. 4, 2, right? Here's what I mean by the crisscross being not always reliable. If we do the crisscross here, we crisscross this up, it makes tin a +2. And we cross this up here and it makes oxygen a -1. Is oxygen's charge -1? What is oxygen's charge? Yeah, oxygen's charge is a -2. This is when crisscross fails, right? So if you do crisscross, you have to check your anion. Oxygen's charge is a -2. So this must have been simplified, right? We must have simplified this. And so it's actually tin 4 oxide. Now, I'm going to show you this with algebra again, because the algebra never fails. It always works. So if this has to equal 0, there's 2 oxygens. So oxygen is a -2 charge, and there's 2 of them. So then that makes this side a -4. So that means this side has to be +4. So this is what I mean by the algebra never fails. So careful. If you like the crisscross, it works like 90% of the time, but 10% of the time you end up with problems like this. So just be careful with it. Okay, our next one would be iron. And again, we can try the crisscross. Now, how can you use the crisscross and make it reliable? All you need to do is check your anion's charge. Check the second atom. Make sure the charge is right. So in this case, your question would be, what's oxygen's charge? And we just talked about that. Oxygen's charge is -2. That means our crisscross is good. So just check your charge. This one's a little tricky. This is mercury 1. This is a polyatomic ion. You'll deal with that more in 219. It's just a tricky one. It's mercury 1 sulfide. And we'll talk more about this next week in our lecture when we get to this one. Okay, so that's how we go forwards and backwards with our ionic compounds. Okay, so what is the name of this compound? I wrote it down here for you. So we have 2 Als.
Aluminum oxide?
Yeah, it's aluminum oxide, right? Now for this one, if this was a multiple choice question, I might have aluminum oxide. I would also have aluminum 2 oxide. But this one is not correct, right? The reason it's not correct is the only time you use these Roman numerals if it's an element that has more than one charge, right? So if the ion has more than one charge, then you use Roman numerals. If there's only one charge, you don't, right? And that's why it's really important, again, to know the staircase. Okay, so let's try these. The first one, we already know this one. The second one, I have to tell you, this is nitrite. So this would just be sodium nitrite. What is number 3?
Magnesium chloride?
Magnesium chloride, yes. And again, we don't need to use Roman numerals on these because they're part of group 1 and group 2. So we don't have to use Roman numerals. All right, number 4, I just told you, here is the polyatomic ion, and that's its name. So what would the name for number 4 be?
Magnesium nitrate? Nitrate?
Yeah, it would be magnesium nitrate. And again, if you don't have this memorized, print out the polyatomic ions or write them out and have them in front of you while you're doing your homework and when you're watching the lectures, because it's very frustrating if you don't have them next to you, and it's really hard to learn them if you don't have them next to you. All right, our next one is barium and oxygen, so it'll just be barium oxide. And type this one in the chat. What would that one be? And do this one on your paper. What would number 6 be? And again, if you're watching this later, write it down now because it's going to be an important one. Yes, I'm seeing lots. So this would be lithium nitride. Again, I want to make sure that you see the difference. Nitride, IDE, that is nitrogen from the periodic table. 8 is a polyatomic. 8 is a polyatomic, right? And so it's really easy to make a mistake between nitride, nitrate, nitrite, right? It's the endings that are really important, like sulfide, sulfate. When you see IDE, IDE means one element from the periodic table. If it is not IDE, you are looking at a polyatomic ion. So those are easy things to make mistakes on. Okay. So do you need to memorize these polyatomic ions? Yes, you do. Not for the quiz that you're taking this week, because there's no polyatomic ions on the quiz this week, but for the quiz next week, you're going to need to know these polyatomic ions. So you will need to memorize them. And I'll tell you which ones you definitely need to know next week in lecture. Okay, now these are a little trickier. Now, why are these trickier? Because they are not 1 or 2. Yeah, these are transition metals, right? And so because these are transition metals, we have to figure out the charges. Now again, starting with a hard one. MnO, if we do a little crisscross, so first of all, hold on one second. I'm sure that, of course, there goes my PowerPoint. I just wanted to grab a periodic table so you can see it really quickly. So hold on one second. I'm just going to grab this periodic table we were looking at. Okay.
Excuse me, Professor, do we need to know ferric and like ferrite or something like that?
No, you don't need to know those.
Okay, thank you.
You do not. Yeah. You only need to know like the actual new names, like the names that we use now. Okay, so hold on one second. I put a periodic table on here, so now you can see it. And because it's really hard to name if you're not looking at a periodic table. It's very difficult. Okay. So now, and I put it on the wrong one. Hold on. I put it on the wrong screen. This is why it's so much nicer actually have it being in class where you can actually see these. Okay, so now I have a periodic table and everybody can see the periodic table. All right, so when we do this, how do we know, again, that we need Roman numerals or don't? Remember, here's our stairs. Anything under the stairs except for this triangle needs Roman numerals. So when we look here, we can see that Mn is in the middle. So this needs Roman numerals. So what Roman numeral will be after the Mn? Right, we don't know. How do we figure it out? Well, remember, it's like an English assignment when you're trying to figure out a word. You have to use the other pieces of the sentence to figure it out. Oxygen charge is a -2. Oxygen charge is a -2. If we do the algebra way, that means that this must be a +2. So this must be manganese 2 oxide. Now, if you did the crisscross way, which again, you can do, but if you do the crisscross way, these are both 1s. So when you flip this up, this looks like it's a +1, and the oxygen looks like it's a -1. And if you do the crisscross, you must ask yourself this question every single time. Is the second element, is oxygen's charge -1? And then you look, well, oxygen's over here. It's a -2. Oh, this must have been simplified. So this is a -2. This must be a +2. But again, if you do the algebra way, you never have to worry about that. The algebra way never fails. Okay, how about for number 2? What is number 2? What is the charge of Mn in number 2? Now we're catching on, right? So again, we could do crisscross. Sure, let's do crisscross. If we do crisscross, this 2 goes up here, but this is a 1. And then we have to think to ourselves, is oxygen -1? No, oxygen is -2. So this must have been simplified. So this must be a +4, and this is a -2. And so this is manganese 4 oxide. Now again, I'm just going to do this on the algebra way so you can see it works every single time. We do this algebra way, oxygen's charge is -2, and there are 2 of them. It has to equal 0. So this must be a +4, right? So a lot of people don't like the algebra way because it's like too much writing. It is, but you end up making less mistakes. So again, whichever way you prefer is fine with me. Okay, so SO4 sulfate. All right, so what would number 3 be? What would number 3 be? Yes, we're getting this, right? So sulfate, I told you, is a -2 charge. So if sulfate is -2, I'm just going to do the algebra way because it makes my life easier up here, then this must be a +2. So this is copper 2 sulfate. And again, the reason we need these Roman numerals is if it is any of these under the stairs, right, it has multiple charges. And so we have to say which one it is, right? Okay, number 4. If you get number 4, that means you got this. So number 4, try this one. This is one of the most difficult ones. So if you get number 4, that means you're pretty good with ionic naming. And if not, it's okay. We still have time. We have a couple weeks we're working on this. So for this one, let's just do crisscross this time. So we do crisscross. Makes this a +3. And this a -1. And remember, we need to check. Is oxygen -1? No. Oxygen's still -2. Oxygen's not a -1. So this must have been simplified. So this is -2, and this is +6. So this must be chromium 6 oxide. Okay, so now I'm going to do it the algebra way, just so you can see. We did the algebra way. Oxygen's -2, and there's 3 of them. So that makes this whole side a -6. So this side must be +6. Again, yes, it is more writing, but it's whichever way you choose to do it. Just be careful. Okay, nitrate again is NO3 minus is nitrate. Okay. So question, somebody had a question for sulfate. So sulfate, this is a polyatomic ion, so it's all bonded together. So this entire thing has a charge of -2. So we don't look at the individual charges when we're looking at polyatomic ions. So this whole thing together is a -2 or 2 negative. So it's almost like its own little unit. So you kind of think of it as like one blob, one thing. So we don't look at the individual elements when we're looking at polyatomic ions. Okay, number 5. This would be iron what? Nitrate. I'm seeing them, yes, iron 3 nitrate. And again, we could do the little crisscross with here. If we did a little crisscross, this would be like a 1. It would be -1, and this would be +3. And then you have to ask yourself, remember, if you do crisscross, you got to ask yourself the question, is nitrate a -1? Nitrate is a -1. So this would be iron 3 nitrate. All right, this is the hardest naming that there is, right? So if you're getting this, you're doing good because this is kind of the most difficult piece. It's trying to figure out what is that Roman numeral. Okay, so now we're going to look at, so these are ionic compounds. Now remember, how do we know it's an ionic compound? We know it's an ionic compound because all of these have a metal. I'm just going to erase all this, try to make this a little bit neater. If you look at all of these, this is a metal, 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 metal. If it starts with a metal, it's definitely an ionic compound because an ionic compound, remember, is a metal and a non-metal, right? So the first question you're going to have to ask yourself whenever you name a compound, you always ask yourself, is it ionic or is it molecular? If you see a metal, it's ionic, right? And then you have to use the ionic naming rules, which is just exactly what we learned. So ionic compounds, again, we always use the simplest ratio. But for molecules, we don't necessarily use the simplest ratios because molecules are the actual number of atoms. So if you've ever looked at like a salt crystal, like if you looked, at the refined salt crystals, they look like little cubes, and they actually look like little cubes. There's like millions of salts of NAs and Cl, but we don't write Na like 1 million, Cl 1 million, right? We simplify it to Na, Cl, because there's millions and billions of them and trillions of them. But for molecular formulas, for molecules, it's the actual number of atoms. So we don't simplify them. Okay, so we're going to practice that a little bit. So covalent compounds or molecular compounds, it's the same thing, and they're used interchangeably. So I'm going to use both covalent and molecular because depending on who your professor is and depending on what book you use, they name them differently. So, and the reason that is because molecules are called molecular compounds, but the bonds that hold them together are covalent bonds. So sometimes we call them covalent compounds, sometimes we call them molecular compounds, which I don't know why, because ionic compounds are held together by ionic bonds, but we call molecules that are held together by covalent bonds. It's just know that I'm going to use them interchangeably just so you get used to it. So whatever chemistry class you take next, you're used to both of those. So a covalent compound or a molecular compound is two nonmetals. So for example, oxygen is a nonmetal, hydrogen is a nonmetal. So that's going to be a covalent compound. Carbon dioxide, nonmetal, nonmetal. So now we're looking at the top right corner of the periodic table, and there's only 3 simple rules to name these covalent/molecular compounds. Rule 1, list the leftmost, or we haven't talked about electronegative, but the leftmost atom first. Number 2, change the last one to "-ide". Number 3, you're going to use Greek prefixes to indicate the number of the atoms. Okay, so remember this from geometry, like pentagon, hexagon, octagon. Yep, you need to know those. We're pretty good. Which ones do we always forget? We forget hepta all the time. Hepta seems to be the one that really gets us. Hepta is 7, but you need to know these Greek prefixes. Okay, there's one exception, and only one exception to naming these. We don't use mono for the first element. Now, what do I mean by that? So we've just done this one. This is carbon dioxide, right? We wouldn't call it monocarbon dioxide, right? So we just don't use mono for the first element. And then sometimes we drop the O or A. So for example, carbon monoxide, we don't leave both O's there. If you accidentally leave both O's there, I'm not going to count it wrong. It's fine. It's kind of like on what it sounds like. And so here you can notice that there's 1 oxygen. We do use mono for the second, if it's the second element. And you'll see this as we practice. And here are those Greek prefixes that we all need to know. So let's practice. Okay, first thing, we list the first atom, the leftmost atom first. Well, carbon, we've got that. And then we list the second element. We just change it to "-ide". So chloride. And then we say, oh, how many chlorides are there? There's 4. Carbon tetrachloride. And that's how we name covalent or molecular naming. Again, we would not put mono here. And only if it's the first one. So it'd be carbon tetrachloride. Okay. So let's try, we'll do this one, we'll do these 2 together. So there's 1 carbon and 4 fluorines. So this would be carbon tetrafluoride. Okay, how about the second one? What would N2O be? This one's a little more challenging. N2O. So try this. Even if you get it wrong, it's okay. When we first do it, we get these wrong all the time. The whole goal is we get them wrong in lecture. So then when we get to our homework, we're better. And then if we get them wrong in our homework, we get them right in our quizzes, right? So this one we have to look. And again, it's a little tricky. How many nitrogens are there? So when we look at this, how many nitrogens do we have? We have 2 nitrogens. So that means 2 on our Greek prefixes is di. So that means we have di, and we just write the element, nitrogen, and then we only have 1 oxygen, so monoxide, or if you want to leave that O-N, I don't care. And again, we do use that mono because it's the second element. So we just say the number, and it's okay. I know it's like, do we do it for the first one? Yep, you do it for the first one. Okay, now how about this one? What will this one be? So write this down, and again, if you can just write it down, and then we'll go over it. Just try it. Even if you get it wrong, it's okay. Just write this down. If we were in class, I'd be walking around making sure you were writing, but I can't do that right now. So yeah, it would be sulfur, and then we have to go, oh, what's 6? 6 is hexa. So sulfur hexafluoride. So 1 sulfur, 6 fluorides. Okay, so now, just a quick review. Ionic or molecular. So every single time that you see any compound in chemistry and you're asked to name it, the first question you're always going to ask is it ionic or is it molecular or covalent? Same thing. Is it ionic or is it molecular? Remember, an ionic compound is a metal and a non-metal, or a metal and a polyatomic ion. Again, how do you know if it's a polyatomic ion? You memorize them. So pretty much, if you see a metal, it's ionic. Unless you see ammonium. Ammonium's like our one little exception to the rule there. Ammonium means it's going to be ionic. So if you see a metal, you're like, oh, it's ionic. And then if you don't see a metal, it's molecular. So non-metal plus non-metal is molecular. So the first question you're going to ask every single time is it ionic or is it molecular? Because there's 2 separate rules, right? So if it's ionic, the next question you ask yourself is it in the middle? And we just showed about what we mean by the middle. If it's in the middle and it's not part of the little triangle, then it needs Roman numerals. If it's not in the middle, easy peasy, you just change the last one to "ide" and you're done with it. Now, if your answer was this is molecular, then you use the prefixes like di, tri, and etc. And we haven't talked about this one yet, but if it starts with H, then it's an acid, and we have a whole new world of naming to come with our acids. Okay, so again, when we're looking at this, here's our hydrogen, right? Our hydrogen is +1. So in the middle, I'm going to use a different color here. Here is our triangle, right? There's 3 boxes that are all +3, 2 boxes that are all +2, 1 box that's a +1, right? Those ones do not need Roman numerals. So everything you see right now does not need a Roman numeral. The reason it doesn't need a Roman numeral is because the charge never changes. So for example, aluminum is +3 always and forever. It never changes, so we don't need a Roman numeral. Anyone else that's under these stairs needs Roman numerals, right? So these need Roman numerals. And it's because their charges change, right? So group 1, no Roman numerals. Group 2, no Roman numerals. Little triangle, no Roman numerals. Everyone else needs Roman numerals. So if you know it, if you see that it's ionic, again, not hydrogen, because that's a non-metal. If you see it's ionic, the second question has to be, where is it on the periodic table, right? That's your second question. Okay, so first question, is it ionic or is it covalent? Or molecular? Well, I can tell you from these are all molecular. So this one, we're just going to go backwards on this. And this is actually kind of nice. Arsenic trichloride. This says that there's 1 arsenic and 3 chlorines. So you just write exactly what it says. What would this one be? You can see, here's this, and here's this one. What does di mean and what does pent mean? So write this one down. These ones are actually my favorite because they're like the easiest, as long as you know those Greek prefixes, right? Yeah, so di means 2. Pent means 5. So we have N2O5. You're literally just writing what it tells you. How about this one? Question is, what does tetra mean and what does dec mean? Right? Dec is one that gets us too. Right? It's these Greek prefixes. You have to remember all the way back to geometry. It was a long time ago for some of us. Yeah, so tetra is 4, deca is 10, so it's going to be P4O10. So once you get the Greek prefixes down, these are like the easiest in the world to do. You just have to remember those Greek prefixes. Okay, now we're going to go backwards. So try these 3, and then we're going to go over them together. So try these now, and then we're going to go over them in just a minute. Okay, let's go over these. So our first one, we have 1 sulfur and 2 oxygens. So that one will be, what did we get for our first one? Yes. Yeah, oh, I just gave you all the answers at once. So yeah, this one will be sulfur, and then 2 is dioxide. Our second one is just nitrogen. And then 3 is tri or ide. And this one, 4 is tetra, phosphorus. 10 is decoxide. If you leave the A in there, it's fine. So if you said DEC, decaoxide, that's okay. Okay, so this is how we name, again, our molecular compounds, different than our ionic compounds. Okay, we're going to try these one more time. So we do this one. Sulfur, I just wrote it for you. Trioxide. What would number 2 be? What would number 2 be? Yep, sulfur hexafluoride, 6 is hexafluoride. Okay, how about number 3? How would we do for number 3? Yeah, this one's a little trickier. So you have to say the number of nitrogens are. So there's 2 nitrogens. So it's di, and you just write the word nitrogen. So 2 nitrogens, and then 4 oxygens, right? Dinitrogen tetraoxide. All right, how about number 4? How would you name number 4? Again, try this one, and then we're gonna go over it in like 10 seconds. So feel free to write it down. Yeah, it's carbon monoxide, right? We use the mono this time because remember, we only use it with the second one, but we do use it with the second one. And our last one is just going to be phosphorus penta, because penta is 5, and then we just write chloride. So naming molecular compounds, you can see, so much easier than ionic compounds, as long as you know those Greek prefixes. Now, there's a few molecular compounds, just let you write this one, last one down. There's a few molecular compounds that have common names, and you just need to remember the common names. Here they are. You need to remember these. Water is H2O. Okay, what is the technical name, now that we've learned how to name these, what is a technical name for water? What should it be called? How should we write it?
Dihydrogen oxide.
So close, so close.
Dihydrogen monoxide, sorry.
Yeah, dihydrogen monoxide. Now, if you want to see the best fake website I've ever seen in my life, just Google dihydrogen monoxide. I think it's like dhmo.org. They have references from like the EPA and the FDA and the CDC, and they reference like thousands of journals about how dihydrogen monoxide is toxic and it can kill you and how bad it is for you. It's actually an incredibly done fake website. This is why, and I always tell my students to go and try this website, because you know your teachers have already probably told you 100 times, don't believe everything you read on the internet. Google dihydrogen monoxide, and you will see why you should not believe everything in the internet. I think somebody just put it in the chat. It's actually like incredibly done. I mean, incredibly well done. Okay, so we don't call water dihydrogen monoxide. We call it water. Another one, ammonia. You just have to remember ammonia is NH3. Now, ammonia is NH3. NH4 plus is ammonium. AMMONIUM. These two are easily exchanged, right? So be careful. Ammonia is NH3. Ammonium is NH4 plus. The other one you need to remember is hydrogen peroxide. This is that same stuff that's the brown bottles in your medicine cabinet. That's hydrogen peroxide. Okay, so those are our 3 that we need to just remember these.